Okay, one final application needed for the homework here, so it's another sort of Gen Chem review. We can do sort of Hess's law for a chemical reaction to use the fact that energy and enthalpy are state functions or thermodynamic variables, that we can think about these cycles and add up different steps to get from reactants to products. So here are the rules here. You manipulate these equations so reactants and products appear with correct coefficients. Because enthalpies are extrinsic, when you reverse a reaction, you have to take negative of the change in enthalpy because you're sort of switching initial and final states. If you multiply by n, again, it's extrinsic, so multiplying by n will make delta H n times as big. Then you just need to make sure everything besides the target reactants and products that you want will cancel up. And the last step is that you can add the delta H's at the very end, and that will basically do one of these cycles where we're writing this sort of going from CH4 and O2 to CO2 and H2O via this sort of circuitous means, just like we did on the last slide. Okay, the one trick with doing these is that in some cases there are a lot of reactions to use. In general, you want to sort of like balancing reactions, we want to use those reactions where there's only one source of a reactant or product first. So, for example, here, if I'm looking at these four reactions, O2 is in, or oxygen here as an example, is in several of these reactions, 2, 3, and 4. In this case, since CH4 is only present in reaction 1, I know for a fact that to get 1 mole of CH4 as a reactant, I need to use reaction 1 as written without multiplying or flipping it anyway. So I'm going to take reaction 1 and use it like that. And I know that has to be right because that's the only way to get 1 mole of CH4 gas as a reactant. Similarly, for reaction 2, that's my only source of O2. So I need to take reaction 2 and multiply it by 2. And again, so this is going to be 2 times delta H2. This is just going to be delta H1 because I didn't multiply by anything. To get 1 mole of CO2 as a product, I need to flip reaction 3. That will give me C gas plus 2O gas goes to CO2. And that will give me negative delta H3 using the rule. And then number 4, I'm going to need to take H2O. I need 2 moles of it as a product, so I'm going to need to flip and double that one. That will give me 4H plus 2O gas goes to 2H2O. And that will give me negative 2 delta H4. At the end, I can check that everything cancels. So C gas cancels, 4H cancels, and my 4O cancels with 2O and 2O. And therefore, my final answer is, in fact, CH4 plus 2O2 goes to CO2 plus 2H2O. And again, now I can just, since I'm adding all of these reactions up, I can add the delta H's because I'm basically thinking about first take the CH4, break it into these gases, then take the O2, break it into oxygen, then recombine some of these gases back to CO2, recombine these back to H2O. So my final delta H here is I need to do all that math. 1660 plus 2 times 498 minus 1598 minus 2 times 934. Just using from the column there. And I get my overall delta H of this reaction is equal to my final answer here, negative 810 kilojoules per mole.